Sorry, just finished up some oatmeal there. On this problem here, we're asked to graph on the number line, so we're just basically going to plot or show an interval on the number line. Graph all the numbers that are closer to 3 than they are to 10. Okay? So in this case, if we think about this a little bit, any number that's over here is clearly closer to 10. And any number that's down here is clearly closer to 3. So our interval is clearly going to cover everything from 3 on down, right? Because everything from 3 on down is clearly closer to 3. If I were traveling from some point over here, I'm definitely going to get to 3 before I get to 10. And over here, on the other hand, these numbers definitely aren't closer to 3, because if I'm starting from down here and I'm traveling, I get to 10 first, long before I get to 3. Right? The question is about the ones in the middle here. Well, 4 looks like it's closer, and 5 looks like it's closer, and 6 looks like it's closer. 7 looks like it's closer to 10. So the question is, where's the cutoff exactly? The cutoff is going to be at the halfway point. If I'm halfway there, then I'm exactly the same distance from 3 as I am from 10. If I move any closer to 10, then I'm closer to 10. If I move any closer to 3, I'm closer to 3. So how do we find that halfway point? We average together the two numbers. So we go 3 plus 10 over 2. So we add them together and divide by the number of numbers, which is 2. So that gives us 13 over 2, which is 6.5. All right? So that number is 3, 4, 5, 6.5 right here. And then we ask ourselves, is 6.5 included? Well, we were specifically told numbers that are closer to 3 than they are to 10. And this isn't closer to 3, it's exactly the same distance from 3 and 10. So that won't be included. So we leave an open circle there. But any number that's just even a smidge over to the left will then be closer to 3. By the way, and this isn't this is kind of a side note, what we're really graphing, anytime you're talking about the distance between two things, you're talking about absolute value. And I would say the distance from some number x to 3 could be calculated as the absolute value of x minus 3. So for example, if I plug in 4 for x right here, 4 minus 3 is 1, and the absolute value of 1 is 1. I'm 1 unit from 3. On the other hand, if I plug in, say, the number 1, 1 minus 3 is negative 2, and the absolute value of negative 2 is 2, I am 2 spaces away. So this expression here will give us the distance to 3 for any number. And I could write a similar expression, right, for the distance to 10, just absolute value of x minus 10. So for example, if I plug in, say, 11, 11 minus 10 is 1. That's the absolute value bar there. So 1, absolute value of 1 is just 1. But if I plug in, say, I don't know, let's see, how about negative 1? All right. So then I'd have negative 1 minus 10, which is negative 11, and the absolute value of negative 11 is just 11. And if I look, negative 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces away from 10. So what I'm graphing here, if I'm talking about all the numbers that are closer to 3 than they are to 10, I can put my two expressions together, and x minus 3 and x minus 10. I want this distance to be less than this distance, so we'll just make it into an inequality. So you can write what we just graphed as this inequality using absolute values.